we'll go ahead and get started if everything works. If not, that's fine.
It goes little lane.
Inverse functions. So tell me one thing you remember about inverse functions, and we'll start with you.
The domain and the range of a function is the opposite for the inverse function. Like the domain is the range.
Okay. So domain becomes the range, and the range becomes the domain. Pretty good.
I know this.
Nick, anything else?
It passes the vertical line test.
Okay. So it has to pass the vertical and horizontal line test. Do you remember what that was called? There's a name for it. Yep.
1-to-1.
Yeah, 1-to-1. That's known as 1-to-1. Do you remember what g of x means from yesterday? G of x means what? It means the inverse. You'll see that, like I said, that's usually reserved for calculus, but since these people are writing the calc in the pre-calc book, they introduced it in this section for the next 4 classes for some people. Yes?
If a function is always increasing or decreasing, it has an inverse function.
Yeah. If f of x is always increasing, that implies it has an inverse. And if f of x is always decreasing for all of x, that implies it also has an inverse. Okay? Do you remember the 3 steps for finding the inverse? Yes, Hannah? All the x's become y's and all the y's become x's. Then solve for y and write the inverse. Okay? So, anyway, those are the 3 steps. And we said all the x's become y's. And what about symmetry? Do you remember what type of symmetry a function and a graph inverse have? What? Yeah, it's over the line y equals x. Okay? Fantastic. All right, so that's a nice way to start. And this way, I think we got to
17.
we got to here, didn't we? We did that one, didn't we?
We got it. That's the last one we did.
Okay. Oh yeah, if 2 functions are inverses of each other, this is f of g of x. They both have to equal x. So g of f of x. I really don't use this unless I have to, and there's some things in calculus that you have to use this with. Not a lot of things, but there's some things. So this is another property of the function, its inverse. All right. So I think we did that one, didn't we? Because we had to have the opposite x's to get through it. But that's another property we didn't talk about before. So, and we already talked about that. That's kind of cool. This one. We did? Easy. Whoever did that. Oh, okay. Oh, it was just a hiccup? Okay, I thought it was something else. Well, that's fine. We can, if we did it, we can move on. F of x and the inverse. What's the domain of this function? William? Good. X cannot equal -3. And if that's the domain, what's the range then of my inverse? Y cannot equal -3. Remember, the domain are x's, the range are y's. Now when you're talking about the range, you're always thinking to yourself, horizontal asymptote. Is there a horizontal asymptote in this graph? We just had tests over that this week or last week. Was it this week? It was this week we had a test. Yeah, the horizontal asymptote's at y equals 0. So it's usually a pretty good indication that y is not going to equal 0. Now sometimes it does cross a horizontal asymptote, but in this case it doesn't. So what's the domain going to be? X cannot equal 0. So there's the domain and there's the range. Now it says without actually finding the inverse, I think just for fun, we're going to get the most out of today. Yeah, I know when people love that. So we're going to switch the y's and the x's with the y's. So what's the first thing? Algebra. Now it's an algebra problem. What's the first thing? Okay, so I switched the x's for the y's and the y's for the x's. No, I didn't write down the number 1. Now I'm moving on. So there's a problem. There's number one. What's the second thing we do now? How do you do that? How do you solve for y? Devin? Who? Multiply it over? Sure. X times y is xy, and x times 3 is 3x. Equals 5. I multiplied it over. Isn't that what you said? I did. I multiplied by y plus 3. X times y is xy, x times 3 is 3x.
Why do you do that? Why can't you just switch the term 5 plus 3 and x? It's like right there.
Yeah, you can do that also.
Okay.
You mean like y plus 3 equals 5 over x? Yeah, you can do that.
Take 3 off.
Yeah, somebody said in this one you would divide everything by x. So you have y plus 3 equals 5 over x. It is the same thing.
Sort of tedious. You don't need to have that step.
No, it's just how people work. They look at things differently. Some people would have done it a different way altogether. So it doesn't matter. Oh, no, at the end, what do you do now? You subtract 3. So you get y equals 5 over x minus 3. Same thing right here. If you went this route, 5 over x minus 3. Now, you write the inverse. Just for an algebraic thing, if you want to write this as a common denominator, you have to multiply 3 with x over x, right? Some people like that answer because they can clearly see the horizontal asymptotes at negative 3. In the other case, you might not be able to, but you can write it either way. You can write it as one rational algebraic function, or you can write it as 2 terms. Both the same way. If you can write rational algebraic functions, the inverses, you're in great shape. If not, you might have some work to do. All right, that was good. See, that's getting the most out of every problem. For this one, we won't get the most out of every problem.
Why?
Well, because I just want to find the domain and the range. What is the domain on the first go around? X cannot equal what? X cannot equal negative 1/9. Oh, that means what about the range then? Y cannot equal negative 1/9. I like that. Like that, Trevor? That's awesome. What about y? What's the horizontal asymptote? Right. Y cannot equal 2/9. Now somebody said, well, how do you really know if that's a horizontal asymptote? How do you really know it can't equal? Well, if you say it can, you write 2/9 equals 2x minus 7 over 9x plus 1. And then you just see, can it really equal 2/9? 2/9 is the horizontal asymptote because they're both degree 1. And so you do the leading coefficient or the leading coefficient. Now you say, okay, does it really work? So you multiply. And you get 18x plus 2. You multiply, you get 18x minus 63. Are those the same expressions? Nay. So it cannot equal 2/9. If they were the same, it could equal 2/9 and you could solve. But that can't be, so it can't equal 2/9. That means x cannot equal 2/9. Okay? Again, on range, people normally think horizontal asymptote. Okay? Fantastic. I don't think we have a 10 for 10 today. I can make one up, though. We'll see how much time we have left. All right.
We're already getting the most out of it. You wanna make-
We want to get more than the most out of today. Anyway, this is how we find the inverse, just for those that have been dozing off the last day and a half, which does happen. Verify it's 1-to-1 first. Yeah, that's pretty easy to tell. Switch x's to y, solve for x, and rewrite it. All right, here we go. You want to try this one on your own, see how you do? Andrew Manalo. Go and give it a go. Don't you get the same thing? I don't know. All we're doing is find the inverse. Are you done already? You don't know what to do?
No.
Or what do you have to do? No? You just find the inverse. Guidelines for finding the inverse. Switch x and y, solve for x. I wonder if that shows up on the video. Interesting. My wheelie noises. Ah. Miss Jones. All right, moving on. What'd you get for your answer? 1 over x minus 3? Okay. Let's see. X equals 1 over y plus 3. And you can switch these terms. Y plus 3 equals 1 over x. Cross multiply and divide or whatever. So y equals 1 over x minus 3. Good. Remember, some people would write this with one common denominator. So it'll be 1 minus 3x over x. That's just to clearly see the horizontal asymptote. You don't have to write like that. 1 over x minus 3? I said you could write it either way. Okay? So either answer will be fine. But if you see this answer in the back, you know where it came from. All right? Perfect. Some are a little bit more challenging than others. This one is one of those. Nothing like a quadratic, but still somewhat more challenging. I'm waiting for some people to put their pencil like they're writing like a human being instead of like a monkey, so they can start actually writing down on a piece of paper and working. That's all I'm waiting for. Interesting grip on that pencil there. How do you write with that like that? That's what I mean. That's how a monkey writes. Here we go. See if you can do it.
The funniest part, as soon as you said something, everyone immediately knew it was true.
No, not everybody knew who it was. There's a couple people.
I don't even think I
Got it? This one's just a tad bit more difficult. That's why I want you to try it. This one, you merely can't switch the x's and the y's. You actually do have to multiply. That's why I prefer multiplication instead of switching. Yx minus 2y equals 4x. I did multiply. Yeah. So I cross multiplied. Yeah. It does. Wait a minute. Yeah, I got just a little bit ahead of myself because I was still thinking about the monkey issue. Y equals 4x over x minus 2. Now it becomes x equals 4y over y minus 2. There we go. Now we're ready to cross multiply. So, I end up with xy minus 2x equals 4y. All right, now I'm back in the game. Now you have to get y by itself. Well, actually, I would get all like terms on the left. No, remember I'm trying to solve for y, so I want to get all the y's on the left. Right, add 2x. So I want to get all like terms on the left. And for me, like terms means I want all the y's on the left. Because that's what I'm trying to solve for. And that's a habit because of using the graphing calculator so much. I always like to put things isolated on the left. So now, how do I get y by itself? Andrew?
Well, below y.
Right, factor.
And you can divide x minus 4.
Right. So y equals 2x divided by x minus 4, which means in the whole grand scheme of things, my answer is 2x over x minus 4. It is. What's the horizontal asymptote in our original function? Do you have any idea what it would be? You can use the inverse to tell me. No. It would be 4.
Wait, oh, oops.
It would be 4.
And it is.
It is. That's how you can double check things. All right? The domain down here would be x can equal 2, so the horizontal asymptote of my inverse would be y equals 2. Okay? Sure. Nice. I think we're ready. Are we done? Is that it?
Ready for the big game?
No, ready for the next question.
Oh.
Are we done? Is that it? Is that all? Or are there more?
I think we're good.
No, I think there's more. See, here we go. I know, this is like a parabola.
No, but it's not 'cause it's a restriction on the domain.
There is a restriction to make this
A 1-to-1.
a one-to-one function. So, x has to be greater than or equal to 0. So, take a look at something. As Megan and I were talking about earlier, the domain of this, let's see, let me erase that. I don't like using that letter. If you take a look at something, the function, the domain is x has to be greater than or equal to 0. So what's that tell you about the inverse? Y has to be greater than or equal to 0. What's the range on this function? If it's a parabola, it starts here and goes up. What is here? What is that point? Some people are just shut her down, waiting for the snowstorm. 2, 0, 2. So that means y has to be greater than or equal to 2. So what's x have to be over here? X has to be greater than or equal to 2. This is great stuff.
It is.
Now all we got to do is find the inverse. Why do I put that up here? Well, because whenever you have a restricted domain, it's a good idea to have that thought in your head when you're working out the problem algebraically. It saves you some time and trouble. So, if y equals 5x squared plus 2, first thing is I switch all the x's and the y's. X equals 5y squared plus 2. Second thing,
Solve for y.
solve for y.
Subtract
Subtract the 2,
divide by 5.
divide by 5.
And put it to 1/2.
And take the square root. I think we're in pretty good shape. Oh, what's one thing about the square root, though?
Plus or minus.
Plus or minus. It would, because it says in the inverse, it has to be positive.
Why did you choose that?
That should be y.
Y, Y, and Y. It is. That's why I'll fix it, and nobody will ever know unless they listen to the video.
We're just like everybody does.
No, they don't. Oh, my geometry class is really getting obsessed with those. It's
We
unbelievable.
actually watch it.
Oh, all the time. No, it's not.
Why?
Because it takes the place of them reading. They figured out if they watch them, they don't have to read.
And they don't get scared.
Right, and that becomes a problem. So, it is going to be only the positive. Because of what Colin said earlier, based on the domain, I want y has to be positive. You see this down here? It says the domain y is positive. That's the only reason you chose the positive square root. And also, x minus 2, sorry. Also, how do you account for getting a 5 by itself in the denominator? What do you have to do? You do. So you multiply by the square root of 5. And most people have forgotten their belly button analogy, that you can multiply things inside the radical. Yeah, the square root of 5x minus 10 all over 5. And what do people want to start doing? They want to start slashing out 5s. You can't do that. One's inside the square root and one's outside the square root. Okay? Well, you had to rationalize it. Right, then you can multiply it through. Correct. Okay? Nice. That's it. But on these, with the restricted domain, you still have to do some, you still have to think about that. I think we should be getting close because I like this question a lot. I know this is towards the end.
It's number 40.
Nice. Use information below to evaluate the expression. Evaluate what expression? Oh, look, here it is. G inverse of f of -1. Somebody goes, look at all that stuff. It looks like a foreign language. It is. It's all Greek. That's where it all came from. So, how in the world are you ever supposed to... Well, you got three different things going on here, don't you? F of x, g of x, and h of x. Now, in this case, g is not the inverse. It's not the inverse of this. That's why I don't like them using g in this book. But anyway, so it's not the inverse. So, first of all, g of f of -1. How in the world are you supposed to do it? Well, first of all, I'm going to look at the f function, aren't I? And am I looking for the f function to have a 1 in the y slot or a 1 in the x slot? Or -1? If I look at the f function, -1 is going to be where? In the y function, right? Because for the inverse of x, you end up with -1, I'm sorry, -1, 2. Does that make sense? I think so. So, what is the g value of 2 going to be? Yeah, it's going to equal 3. You're looking right here at 2, and it's going to equal 3. So the whole thing equals 3. Those are fun. Those are exciting.
Can you go back up to the graph?
That was it.
I'm confused.
About what?
So if you go -1 equals 2, then you find 2.
Right, if you go -1 to 2, that means f inverse of -1 equals 2, right? So, f inverse of -1, that equals 2. Now you go to the g function. When x is 2, what's y equal? 3. You can't even use h. That's for the other problems. These are so much fun. Yeah.
Number like 40 over here, if someone find it, it just says f of x equals -x. Find the inverse function. How do you do that?
F of x equals -x.
Yeah,
You do it the same way.
this equals -.
First thing is you switch all the x's and the y's. X equals -y. You solve for y. Y equals -x. And you write f inverse.
That's all it is.
So it just goes back to the original.
Right.
I thought it was going to be more complicated than that.
I don't think so. All right, good. Sounds good. Moving on. I couldn't set a better. Oh, another one. This one you can try your own. Yeah, same chart.
There's 2 numbers.
All right. So it's that you can't do this all at once. Like people try to eat a pizza in one bite, it just can't be done. You have to take small bites. No, it can't. Yes, Miss Susan. I don't know. Let's find out. I haven't done it yet.
You can take those little multiple squares.
Inverse. So for the inverse g of 3, that means I have to look. This is the first part, right? Because you can write this function compositely. So the inverse g of 3. That means for regular g, I have to look to where y is going to be 3. Yeah, so that's going to equal 2. All right? I don't know. I'm happy I got the 2 right now. And now I'm moving on. So the inverse of 2, well, that means I go to the f function, and I look to where 2. So I'm looking where what? Where in the f function y equals 2, don't I? And that gives me 5 for the x. You notice how the inverses kind of flip everything like you're going backwards instead of forwards? That's exactly right. So it's 5. I would suggest trying some of those because I really like those problems a lot. I know, so give them a go. No, later on in your homework, make sure you know how to do those. Oh, there's more than one. I like those problems a lot. But yeah, here's another one.
Oh, well, there's 3 for the problem.
Look at that. Here's another chart. On this one. So let's give this one a go. The inverse of h, the inverse of g, and the inverse of f, and 6.
So is it f of 6?
So yeah, so it's h inverse of the g inverse of the f of 6. So give it a go, and I'll give you a minute to work this one out. Nope. That'll be your final answer. Let's see, I got, my first step would be 3. Because I went from 6 to 3. Got it. And now I go to the inverse of g. I'm looking for a 3, but on the g function, that would be a y value. So that equals 2. Because it's the inverse. Right, the inverse, the points on the inverse of g of x are all reversed to this. So it'd be like 1, -1, 3, 2, and 5, 3. Then I'd have to do the h inverse of 2. So, I don't have any list of points. But 2 would be what on h?
No, it'd be the range.
It'd be a y value. It'd be on the range, wouldn't it?
So you plug in -2 for 8.
No.
Well, what h?
If I have h of x, I have 2 choices. One, if I put 2 in, I got the point 2, 2. That's odd. That means you're safe either way. You don't even have to think. I hate that. You should have to make a choice.
So the answer is 2?
Yeah, the answer is going to be 2. See, you're supposed to have 2 choices. 2 with something else, and then 2 with something else. You have to decide which one's which. Yeah, in this case, it would be A is the right answer. Oh, no, I didn't like that at all. That's a dud.
How do you like these problems?
I did until that one came out. That was a bad taste in my mouth. All right. Oh, I love this. Everybody in kindergarten can do this. I gave it to my daughter yesterday. I said, draw this picture. She drew it. If the point 10, 9 is on your function, what point's on the inverse? 9, 10. This point on this line means that x equals y, doesn't it? That point's on my inverse. This point's on my inverse. What about the point 1, 0? It becomes what? 0, 1. Distance is preserved over reflections. The distance is the same. Okay? The distance is preserved over reflection. We just did this in geometry today. We reflected things.
That's all you have to do. I didn't really do that.
Yeah, that's for part A. Yeah. That's to draw this picture. Drew it. I connected. I put the dots on there for her, though. She connected it. Yeah. What's the domain of the function?
So you just find the domain of the function and then
This is the same one. So what's the domain of this? What x's am I using?
1 to 10.
1 to 10. What y's am I using? 0 to 9. Remember the brackets means including? The inverse. What's the domain?
0 to 9.
0 to 9. And what's the range? 10 to 1. Oh, 1 to 10. Somebody up here said 10 to 1. It's 1 to 10. You always go in ascending order. Okay? And is that true on the picture I made? This is 9 to 10. And this is, yeah. So the domain went from 0 to 9, and the range went from 1 to 10. So it matches up.
Very nice.
Excellent. Is there a part C to this, I hope? It is! Find the domain and the inverse. Oh, I'm getting the most out of today. What can I say?
Yeah.
I think we've gotten enough so far today.
We're done?
Yeah.
Oh, no, we're just taking a break.
Rain break.
That's literally. Oh no, we're not.
We're done.
That's it?
Yeah, that's it.
Are you sure there's not any more? All right, so how far are we going to? 70?
47.
80?
47.
There is no 80.
90?
47.
You are dreaming.
No, I think we'll go to... No, I like the ones with words on them.
I like the ones with words.
Yeah, I think you can read. Don't sell yourself short.
Mr. Berries, they all have words on them. It says verify that. That's a word.
Yeah, so we go all the way up through 51. So what page is this?
288 through 289 through 290. That's
Page 288. All right, that's not going to work, obviously. It hates when I try to write on my PDFs. I don't know why.
I can see those online.
You can't.
Mine.
All right, page 288
290, yeah.
to what? 19 to 51 odd.
I already did it, so just add on with yesterday.
All right. Sounds good. I'll see if this were actually recorded.
You like to see the actual video that you put up?
Yeah.